In this video, we're going to be looking at different types of functions. Last week, we talked about whether or not something is a function, but today we're going to be looking at different types of functions. So we have two types here that we're going to talk about, linear and nonlinear. So a linear function is a function in which the group of solutions forms a line, and a straight line at that. A nonlinear function is a function whose rate of change is not constant, and its graph is not a straight line. So let's take a look at some of these examples. First one up here, let's take a look at this. So we have a graph of a line, and it is a straight line. So this would be a linear function, okay? For this second one up here in the middle, that is a curved line. So the rate of change is not constant there. It's changing at different amounts. It is not a straight line, so this would be a nonlinear function. I'm going to abbreviate it to NL. Okay, if we look at here in the bottom left-hand corner, once again, that is a curved line. So because it is not a straight line, this would be nonlinear as well. Okay, this one here on the bottom in the middle, this, even though we have dots along the line, if you connect those dots, it does make a straight line. So this would be a linear function. And then lastly here on the right, we have this graph that looks a little strange. So we got to look to see if consistently overall do the points form a straight line. So because it's broken up here into different segments with points at different spots, this would be a non-linear function as well. So it really is as simple when you look at a graph to determine if it's linear or nonlinear. It's as simple as just identifying if it is a straight line or not. That's what's going to help us determine if it's linear or nonlinear. There's only one instance where a straight line is not a linear function, and that is when we have a vertical line, but we'll talk about that more later. All right, now let's take a look at some tables. So not always will you have the graph already available to you. Sometimes you'll be given a table to figure out if the function is linear or nonlinear, and you can always graph from the table, but I'm going to show you a way that doesn't involve graphing to be able to figure out nice and easy if it is linear or nonlinear. So let's take a look at this table in the top left-hand corner. Just like we did last week, we're going to find the rate of change or the slope from the table and figure out if it's a constant rate of change or not. So we can do that by figuring out our change in y over our change in x. So here, if we look at our y column, we would be adding 1 from 1 to 2. Okay, but then when I go from 2 to 4, now I'm adding 2. And then when I go from 4 to 8, now I'm adding 4. Okay, along that left side, each way I am adding 1 as we go from each number to the next, okay? So we have to look to see on both sides, is it a constant number that I'm either adding or subtracting to get the following number in the table? Since here on that y column, we don't have a consistent number, it jumps from 1 to 2, then to 4, this would be non-linear. And again, because it's not that constant rate of change, that's what makes it nonlinear. All right, let's take a look at the next example in the top right-hand corner. So let's look at our change in y. Once again, we're going from -5 to -6. To go from -5 to -6, we are subtracting 1. Then we're going from -6 to -7. Once again, we're subtracting 1. And then going from -7 to -8, subtracting 1 again. For our x column, we are adding 1 on each side to go from 0 to 1 to 2 to 3, adding 1 at each step. So because this one has that constant rate of change, we're on that y side, we are subtracting 1 at every step, and we're adding 1 on the x side. Because it's that constant rate of change, this one would be linear. Now that you've seen a couple examples, I want you to go ahead and pause the video here and try these two tables down here at the bottom yourself. Using that same process we did for these first two, figure out if the rate of change is constant. If it is, that would be linear. If it's not constant, then it'd be nonlinear. So go ahead and pause the video, try these two on your own, figure out if it's linear or not, and then come back to the video here once you're done, and let's check to see if you got it correct. All right, hopefully you've had a chance to try these bottom two. If not, again, please pause the video and try them yourself first. But let's take a look at the one on the bottom left. So here on our y column, we're going from 1 to 0, so we're subtracting 1, but then we're going back to 1, so we'd be adding 1, and then adding 3 for that to get from 1 to 4. Okay, we are adding 1 on each side of the x column, but because it's not that constant rate of change here on the y, this one would be non-linear. Okay, then for the one on the right, again, let's figure out our change in y and our change in x. So for change in y, we would be adding 1 this first step, but then going from 1 to 8, now we're adding 7 and then adding 19 to get 27. Okay, while we are adding 1 on the left-hand side for our x's, once again, because it's not that constant rate of change on the right-hand side, this one also would be non-linear. All right, now that you've seen the difference between linear and nonlinear, it's time to practice it on your own with today's assignment. If you missed any parts, feel free to go back and rewatch it to make sure that you truly do understand this before trying your assignment today.